Well, good morning. It's 11 o'clock on going blank on what day of the week it is. This is Tuesday, the 29th of August, 2017. It's supposed to be linear algebra class. Right now I'm the only one in the room, so hopefully some other students will be coming in soon. But let me first start out with the apology. I had told y'all, I think, or if I didn't, I meant to, that I was going to carry all the materials that I needed, I'll try to carry everything I needed over to the Birmingham campus on Friday, where I have the biggest chunk of office hours I have all week, 7:45 to 11:45. However, I didn't have that much, but I was supposed to have. And I did carry it over there, but before I could get started on updating Blackboard for any of the classes, because I'm the math department chair, I had the 3 classes left to cancel, okay? So I needed to cancel the 3 classes, and of course when I cancel a class, I always try to call the students before I cancel to let them know. Also, I usually try to call the instructors as well to let them know not to come to campus, so that was my intention. Well, I got into the office, got settled in, my computer was set up and working and that type of thing, and got started. And the first class I was going to cancel, I pulled up the listing of students, called the first student, and about the time I was finishing that phone conversation, or I can't remember if I had a conversation, just left a message, but in came somebody, and it never stopped. For the rest of the day, I never had a chance to get back and even call the second student in that class. I had people coming in to register. I had faculty members coming in to comment or gripe or complain about something. I had just a variety of things just all morning long. And ultimately, we had a meeting. I told you they love calling meetings on Friday. We had something, actually, it was our director of library services was retiring, and they had a thing for her that I had already said that I would go to, so they were expecting me to be there, so I needed to go, but I got there really late just because I got called. I was running stuff by the personnel office, the vice president's office, the human resources office. I had all these things to do. And, of course, most of the people weren't in their offices because they were already at the retirement thing. So I couldn't get half done what I needed to do. And ultimately, when I was in the registrar's office to get something done for a student, I don't even remember what it was right now, then the director of admissions wanted to talk with me for a while, so we talked for a bit. And then when I went to leave there, a student couldn't find his advisor because his advisor was at the retirement thing. So I helped that student. So I was late getting the retirement thing. By the time that was over with, I went back to the office. I didn't have time to do a lot more then. So I had to cancel the 3 classes without calling any but one student in one class. So it was really discouraging and disappointing. So I took all the stuff home with me to work on it over the weekend, but we were out of town for part of the weekend, and so I couldn't get some of it done there. So when we got back in town on Sunday evening, I started working on it and got a lot of the corrections made, but when I went to upload things to Blackboard, could not. Blackboard was down, and I couldn't get anything loaded on Blackboard from home. I was also, so I turned around and brought it back to work on Monday. I had classes all day yesterday until 3:15. At 3:15, finally I got to work on bringing things in. But even then, I had issues with books. I had issues with instructor copies. I had people calling me, coming by, all sorts of things happening. So I got my first class on Tuesday, Thursday, the Math 112. I got everything loaded on Blackboard. Well, no, I didn't, okay? I had to leave before I could get everything done there. But again, I took everything home with me And last night, I finally finished uploading everything on Blackboard with 112. It went a lot slower than I expected because I had to leave my calculator here for Dr. Bryant to use in his physics classes. So at home, we had an old laptop that I was using that had that sorry program, Windows Vista, terrible operating system. It didn't work well with Blackboard, so everything took too long. And basically, I only got Math 112 done. I was hoping to get 113. In fact, I started trying to work on 113 after I finished with 112, and then the computer battery went bad. Or not went bad, it was discharging. It wouldn't let me work anymore until I went back to recharge the battery. By that time, it was too late. I went to bed. So, hopefully, I'm going to carry things home with me again this evening, but I think my wife has a whole string of things for us to do this evening. So I may not get anything done today. Tomorrow afternoon, I have another 2-hour period. I've got to make 2 purchase orders, but after I get those done, I'll be back. Hopefully, we'll be able to get some things loaded. So, sad story. I was just explaining, and you'll have to listen to it on YouTube, why I didn't get your Blackboard updated yet. It seemed like Friday, the weekend, yesterday, and last night, if anything could go wrong, it did. Okay, so not quite. I did get one class completely done, but I didn't get the others much progress made on them at all. Okay. Any questions on anything we've done up till now? Okay. We're in section 1.1, page 9. Chapter 1 is Systems of Linear Equations. 1.1 is Introduction to Systems of Linear Equations. And we're down to the discovery at the bottom of page 9. This is the last thing in this. And it's saying graph 2 lines represented by the systems of equations. Use Gaussian elimination to solve the system. I can't for the life of me figure out why they want us to graph them. They're not hard to graph, but why? The Gaussian elimination is pretty straightforward. Let's do that, since that's what we've been doing. Here's a system of equations. Let me get my pen set up. Okay. X minus 2y is equal to 1. Oh, I forgot to turn it, yeah. Those students are in here, I don't turn on the projector, I forgot to turn it in. Oh, when you came in. Okay. 2x, or x minus 2y is equal to 1, minus 2x plus 3y is equal to negative 3. All right. Now, how would you do Gaussian elimination with that? What's the first thing you want to be true? Yeah, it is. Fantastic. We don't have to do a thing to make that happen. What do we want to happen next? Not 1. 0. How do we make that become a 0?
Multiply the first equation by positive 2.
And add it to the second. Very good. So we'll multiply 2 times equation 1 plus I should have written this down here. Okay, sorry about that. Okay, now what would that yield? Since we're using the first equation, I'll write it down. X minus 2y is equal to 1. Okay, let's do what we just said there. And what do we get?
So 2x minus 2x
is 0. Okay.
So 2 times negative 2 is negative 4. Negative 4 plus 3 is
Negative y.
And then there will be 2 minus 3
Negative 1. Okay. So what does that give you? What does the second equation give you? y equal 1. I'll just change those and make it y equal 1. Then what do we do? Huh? Yeah, plug it into the first one. So that would be x minus 2 times 1 is equal to 1. That would be x minus 2 equal 1. And what do we do? So add 2 to both sides, and you get x equal 3. Okay, so you get your point of intersection is going to be 3, 1. Okay? It said to graph those two, I don't see any real reason. Do you like to just review graphing real quickly and do it? Okay. It's fine to do it, but yeah. All right. So homework exercises, I think I gave these last time. Any of the odds 1 through 5. Oh, and by the way, here's one of the things. I was talking about what occupied my time yesterday afternoon when I was hoping to do things. I found out that there's a new edition of this. Do you have a book yet? Okay, if you buy it at the bookstore, it's going to be a newer edition. It won't look just like this. Okay, same author, everything is the same, except it's 8th edition. However, if you can buy this old one, I don't have the new edition either. Like I said, I just found out yesterday where I was in the bookstore trying to get information about the new edition of fiscal of pre-calculus algebra text. That I just found out they had ordered a new one for that. I was trying to find out information from that, and I noticed this had a new edition. And we went to a new book for Calculus 1, so I checked to make sure of that. So I was doing that yesterday, and that's when I found out we have a new one here. If you want to, if it's cheaper for you and you want to use this one, you certainly can, because that's all I've got to teach from. Generally, there's very little difference between editions. The main reason they come out with new editions is that the publisher does not make money selling used books. They only make money selling new books. Other people make money selling used books, but not them. So they like to come out with new editions every 3 or 4 years just so they can sell a bunch of new books, even though there's hardly any change in the editions. Okay, so homework exercise, any of the odds 1 through 5, either 7 or 9 or both, any of the odds 11 through 23. A few of those have decimals and fractions, those will be fun. Any of the odds 25 to 29. Any of the odds 31 to 35. Any of the odds 37 to 55. Either 57 or 59. Now, both of those have either decimals or fractions, so those are a little more involved. They say use a software program, but you can do it without it, but it can be a little bit challenging. Either 61 or 63 or both. Do 65, and then you can look at 67 and or 69. Oops, there's another page. 71 or 73 or both. 75 is another interesting one to do. So, and then 77 through 81 are kind of interesting. They're sort of approaching it from the other angle. 85 would be a decent one to do. Again, it's a little bit different type of a problem. 85, 87 are basically think-through issues. 89 is a think-through discovery. And 91 is another one that more writing, but it's just sort of think through it. All right, any questions on 1.1? All right, 1.2, I believe I was that close to finishing the section and didn't realize, yep, I was, okay. 1.2. I think I'll clear the ink on this one just because there's going to be a bit of writing here, I'm afraid. Okay, that 1.1 was a review of linear equations, an introduction to Gauss elimination, back substitution. We're going to do the same thing now, but now we're going to talk about Gaussian elimination and later Gauss-Jordan elimination, but now with matrices rather than systems of equations. And basically, they're almost identical. Okay? So here's the definition first of a matrix. And this on about midway through second class this morning, my head started clogging up. Now my throat's beginning to hurt. I think I just don't like talking for 4.5 hours in a row in the morning. It just is a bit tough on the throat. All right, here we have M and N are positive integers. Integers, that's what that's supposed to represent. Now, we're going to talk about an M by N matrix. You don't talk about matrices with fractional or decimal number of rows or columns. That just doesn't make sense. So M and N are positive integers, and then you can talk about a matrix made up M by N. Those are positive numbers. Okay, now what does that mean? That means you have M rows. Row 1, row 2, row 3, ... down to row M. You have column 1, column 2, column 3, ... down to column N. M by N. So that's the number of rows or columns you have. Okay. Now, the entries, the elements that are in the matrix. This is not the matrix. This is how we describe a matrix. A matrix is usually given inside angle brackets. Okay, that array of numbers. Okay, and here's typically how we refer to those elements. If this is matrix A, say, capital A, we usually name matrices by capital English letters. Okay, if that's matrix A, then we put the elements of this, the various numbers that are in the rows and column, as A11, A12, A13, ... down to A1N, A21, A22, A23, ... down to A2N. A31, A32, A33, ... down to A3N. And then we keep going ... downward until we get A sub M1, A sub M2, A sub M3. Goodness, my writing gets worse and worse. Okay, ... down to A sub M N. And all these are ... dots. Everywhere ... Okay. That is an M by N matrix. Okay. Any M by N matrix, any array of numbers, it doesn't have to, usually it does stand for something, but it doesn't have to stand for just one thing. I mean, usually it does stand for one thing, but a matrix isn't just for solving systems of equations, though it can be used for that. It could be for a whole bunch of different things. And that is what we mean by an M by N matrix. usually denoted by capital letters, and most of the time then we'll use a lowercase letter to indicate the elements in those matrices. Okay, now let's look at those subscripts here. The first subscript corresponds to the row number. The second subscript corresponds to the column number. Okay, and if this has M rows, and by the way, when we say M by N, it's always rows by column. That means you have M rows in columns. So you have a total of M times N entries in that matrix. Let's just say if that was a 5 by 3 matrix, that would be 5 rows, 3 columns. 20 by 20, 20 rows, 20 columns, okay? Whatever you have. It could be 7 by 17, 7 rows and 17 columns, okay? You could set it up any way you want to. 17 by 7, 17 rows and 7 columns. Whatever you have, that's a matrix, okay? Notice there's no variables in it, though variables may relate it to these things. I say no variables in it. Yeah, you'll see them do little things like make this one X or something like that and say, what does it take to make that a certain kind of matrix? So occasionally you may have that. Okay. Now, a couple of other we call that M by N basically the size of the matrix, okay? That indicates size. Another type of matrix, special type, is when M is equal to N. In other words, you have the same number of rows as you do columns. That's called the square matrix. Now, if you have a square matrix, then we'll refer to this entry here as the diagonal of that matrix. If M is equal to N, then that would be your diagonal matrix, your main diagonal of the matrix. Okay? There is a second one, but we usually don't ever refer to that because it doesn't really have much application. Main diagonal does. So, next group of things, really simple. We're going to name the size of matrices. Okay? And this, there's hardly anything to it. Let me erase all this. Is that a matrix? Yeah, actually it is. What's its size? 1 by 1. A single entry, 2. Now, most of the time we don't use those, okay? But that technically fits the definition, okay? Is that a matrix? Yeah. What size is it? 2 by 2, exactly. It's also called a square matrix. And technically, that's a square matrix. Number of rows equal number of columns. Okay? This also has another special name. That's the zero matrix. Okay? Because every element in it is 0. Okay? That's the 0, 2 by 2 matrix. Okay? How about this one? All right. Come on, right? All right, we're in 1.2. We finished 1.1, gave you homework assignment, and then we're into 1.2. We're on example 1, bottom of page 13. 1.2, sorry. Bottom of page 13. Here's a matrix. E, 2, negative 7, pi, root 2, 4. Is that a matrix? Yeah, it is. Okay, a few things different about this from the first two. Number one, name some differences. And that third matrix are the first two.
What's those in the second matrix?
Second matrix are all zeros.
All zeros?
Yeah.
Third matrix got a letter, got an I,
Okay. What is that letter? It's an E. The what? It's not what? It's the exponential number. It is a number. It's an irrational number. It's the base of our natural number system. 2.71, blah, 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 blah. It goes on forever. It's an irrational number. It doesn't repeat a pattern or anything. It's actually a number. Just like pi is a number. Another irrational number. Square root of 2 is a number. An irrational number. So this has three irrational numbers. Half of the elements are irrational numbers, and half of them are integers, in fact. Rational numbers. Okay? What's the size of that matrix? Say again? 2 by 3. 2 rows. Yeah. 2 rows, 3 columns. 2 by 3. Okay, the first two didn't have any minus signs in them. That one has a minus sign. No sweat. Okay? That's a matrix. It's a group of numbers, and it's a 2 by 3 matrix. All right. Now, like I said before, goodness, my throat's hurting. There's many things you can use matrices for. One of them is systems of linear equations, like we were doing in 1.1. And that's what we're going to focus on first. And pretty much foremost. That's not going to be the only thing we focus on, but we will focus on that to begin with. So here's a couple of more terms. Okay? First, I'm going to write a system of equations. X minus 4y plus 3z equal 5. Minus x plus 3y minus z is equal to negative 3. All right, 2x minus 4z is equal to 6. Goodness, I'm not feeling very well. I felt great the first two classes, and well, toward the end of the second one, I was getting clogged up. Now, all right, that's a system of equations. Okay, we're going to write that as a matrix. Okay, and it's going to be a special kind of a matrix. It's called an augmented matrix. And here's what makes the augmented matrix. Okay, what we're going to do is write down just the coefficients. Matrices usually don't include variables in them. They can, but not for this. All we do is write down the coefficients. Now, what's going to be augmented about it, we're going to do the coefficient matrix and then augment that by your constant matrix. Okay? And that's going to make it the augmented matrix. So that's just going to be, say again? Okay. We could. The book does them in different order, but let's do it the way you said. Let's just first do the coefficient matrix. What would that be? Okay? Yes, very good. -4. That's the coefficient matrix. Okay? Now, is there a question? Pretty straightforward, right? Here's the deal. The rows correspond to equations. The columns correspond to the variables. Okay? Everything in the first column is the coefficient for the variable x. Second column, variable y. Third column, variable c. Very good. Now, the augmented matrix is where we take that coefficient matrix and augment it with the constant matrix. You could call it a vector. 5, -3, 6. Okay? That now is what we call the augmented matrix. The square matrix, 3 equations, 3 unknowns, that happen to be in this case, was your coefficient matrix. When you augment that by the constants on the right-hand side, that makes it the augmented matrix. Okay. And we'll be working with those quite a bit. Okay? Now, of course, you could have more equations if you needed them. You could have more unknowns if you needed them. So that would increase your number of rows and or the number of columns. But if we're dealing with the augmented matrix, sorry, then you'll have that one more column at the end. It doesn't correspond to a variable, but corresponds to the constants. Okay. Now, before we talked about the operations you could do to a system of equations, almost identical, we're going to talk about operations you can do to a matrix. And these are called the elementary row operations. I kind of wish I could leave this up because I think we're going to use it again, but I just don't have room, so I've got to close it down. Okay. Here are you tell me what the 3 legal operations you can do to systems of equations. 3 things you can do. Interchange any 2 rows. Multiply by what? Yes, multiply, and that also includes or dividing by any non-zero number. An entire row by any non-zero number. Okay? And the third one? Multiply one row by a number, add it to another row. Those are the 3 things you can do. And we've done them. Okay? Well, your elementary row operations will then be very similar. Remember, the rows corresponded with equations, so now you can change any 2 rows, just like you could change any 2 equations. Okay? Another thing you can do is multiply any row, which is an equation, by a non-zero number. Multiply or divide by a non-zero number. And the third one is add a multiple of one row to another row. And that's what we did when we're getting it. And why did we do that with systems of equations? Trying to get it into trying to get it into what we called row echelon form. Right? Remember that strange word? We do the same thing with matrices. We get it into row echelon form. The elementary row operations were the same thing that we did with equations, systems of equations, and we get it into row echelon form, which is the same thing that we have with equations. Remind me what row echelon form is going to look like. Start with the first row. First non-zero entity, element of that has got to be a 1. And we want zeros below that 1. Okay? Second row, first non-zero entry, another 1, and zeros below that. And on down the way, and you want your leading ones to be stepping to the right as you go down the list. Okay? That's what row echelon form for a matrix will look like, just like it did for an equation. Now, a little bit later, we're going to have another feature in there called reduced row echelon form. Okay? Right now, we're going to focus on row echelon. Okay? So, let me back up for a minute. When I was giving the homework exercises for section 1.1, I meant to point this out. I don't remember if I've said it before, but I want to say it now in case I did. This author, by the way, I guess I have reviewed getting close to 10 different linear algebra texts. I'll tell you right now, I do not like Brooks Cole's Engage Learning. It's not my favorite publisher. Okay? It's my boss's favorite publisher, but it's not my favorite. Okay? But let me say 2 more things. Okay? When I reviewed from all the different publishers, everyone that sent me a book, the one that matched most closely with what our course description is was this one. I mean, it's almost like the guy read our course description and said, okay, these are the chapters I'm going to put in. They almost follow the same order, okay? So that's one reason I chose this book. But more than that, this author, Ron Larson, he has the best supplementary materials of any author I've taught from. Now, what's missing on this book? PowerPoints. I wish he had them. He doesn't, okay? Even a good test bank, he doesn't, okay? This is a specialty type course, so I guess they just haven't paid him enough to come up with those supplementary materials. But here's one thing he does that not many other authors that I found do. Every homework exercise, it says here, see www.calccheck.com for worked out solutions to the odd number exercises. So there's 2 reasons I give you odd number exercises. Number 1, the answers for the odd numbers are in the back. So if you work the problem, check your answers in the back. If you got it right, go to the next problem. However, if you didn't get it right, then see if you can figure out what you did wrong. If you get stumped, don't let it discourage you. Go to calccheck.com and you'll find the worked out solutions and you'll see the stuff that you missed. So there's no reason to get frustrated, tied up with it, angry at it, having to come in and ask questions in class. You can answer a lot of those just going to calccheck.com. Fantastic resource. Now, he's the same author we use for pre-calculus algebra. That book sells a lot more copies because everybody takes pre-calculus algebra. He also has 2 other features in that book besides calccheck.com. He has one feature that he does in that book. After every example, he gives you a checkpoint, I think he calls it. A couple of other problems very similar to that example. And I highly encourage people to go home and work on those right after. This book doesn't have it. Sorry about that. But in addition to that, he has those checkpoints at larsonprecalculus.com. He has worked out solutions for that. Sometimes videos, sometimes other aids. And then there's another thing he has on the new book, new edition, is calcview.com. I don't know what that does, but he has 3 online packages that supplement the material in that. Here he only has one, caltrack.com. But it's a good one, so I highly recommend you use it. Okay. Yeah. Yeah. Okay. And that's what I was saying before either one of you came in. Okay. They're on YouTube, but they're not on Blackboard yet. Now, if you know enough about YouTube, you can search my name. You can search math. Search math 237. You can search those things and find them. Now, you'll find a whole bunch there because I've taught this course several times, but find the most recent one, the ones that were updated. I think it says like 2 days ago, a week ago, something like that. If it gets months ago, that was last spring or summer. But if it's just a few days ago, that was this term. They're all out there. You can look at any of them you want to, but the ones that we've done in class are there. Now, to get to your question, though, I said this earlier, and if you go back and listen to the first part, you'll hear it. I think I told you last Thursday I was going to be taking all the materials I could with me to the Birmingham campus, because the biggest chunk of office hours I have all week are Friday morning, 7:45 to 11:45. That's the biggest chunk. Okay. However, I'm also a math department chair, so Friday I had one thing to do before I could start putting things on Blackboard. I had to cancel 3 sections of math that the numbers were just too low to support the instructors, to support holding. And usually before I cancel a section, I like to call all the students in that section to let them know it's being canceled. Well, I got there, 7:45, first one in the office, and got set up, my computer room plugged in, all that kind of stuff. And then I started the process of, I had to get all the programs loaded and stuff like this. So I pulled up the stuff and started calling the first section I was going to cancel. I got 1 student called before people started coming in, and they never stopped all morning long. Literally, I did not get back to call the second student until I was supposed to leave at 11:45. It was 1:30 or 2 o'clock or 2:30, something like that. Still had to call the second student. It was just a crazy day. First week of class is always like that. So no, I didn't get anything done on Blackboard. So I took all the stuff home with me, hoping I'd be able to have some time over the weekend. Well, we went out of town for part of the weekend, so that ate part of that. When we got back in Sunday evening, I started working on it and got a lot of the materials updated. But when I went to load them on Blackboard was down. So I couldn't do that Sunday. So I came in yesterday, and only office hours I have on Monday and Wednesday are 3:15 to 5:15. So I thought, please let me have some time. Well, I had a variety of other things that came up. People interrupted, came in and stuff. But I did get my first course, most of it uploaded on Blackboard, not all of it. Ran out of time there. Took it home last night and finished uploading my first course, the Math 112. But I started on 113 and my computer battery went out. I had lost all its charge, or most of it. So I had to quit that. But I leave this computer here on Monday, Wednesday for Dr. Bryant to use in his physics class. So I had to use a laptop we had at home. It's an old one, and it has Windows Vista, which is one of the worst operating systems I've ever seen in my life. And it was really interacting poorly with Blackboard, so things took so long to do. So that's why I only got 1 class done. And then by the time I finally finished that and went to work on the second class, that's when the battery died. So I had to plug it in, and before it recharged, I said, I'm going to bed. So hopefully, I'm going to take things home again tonight, but I already know my wife has this honey-do list about this long to do, so I may not get it much done tonight, but I do know tomorrow afternoon I have 2 hours of office hours, 3:15 to 5:15. However, I also know I've got to, this is the last week that we can do requisitions. And Friday, this is one of the things that slowed me down Friday. One of my instructors told me her printer was dying. Could I order another? So we had to call the people to find out who we were ordering printers from, and stuff. And that person sent the information. While I was doing that, I said, my cartridge on my printer is dead. Who do I order this from? They used to have a company that did it. They don't do cover my printer anymore. So I have to order it. So she was trying to get me that. She hasn't got me that. She got me the other. So I've got to do 2 purchase requisitions tomorrow afternoon. So I know that will take some bit of time, hopefully not too long. But then I've also everything else that comes up. So I'll try to get things on Blackboard soon. But you can access the YouTube videos just going straight to YouTube. After I get it set up, all you have to do is go to the course link, the content, and go to that thing, click on it, you'll go right to the playlist. And you won't have to search for it. Okay. Any other questions before we go? Let's do example 2. Here's a matrix. 0, 1, 3, 4. -1, 2, 0, 3. 2, -3, 4, 1. Now, I may do a little bit more than what they intend. They tell you what to do. I'm going to do it slightly differently. If you were to try to get this in row echelon form, what would you want the first thing to do? Be? Yes, you want the first entry of the first row, the first non-zero entry to be a 1. The first non-zero entry is a 1, but we'd rather have that being a 1. So how could you get this matrix to make that happen? Absolutely. Exchange those 2 rows. It won't be a 1, it'll be a -1, but that's easy to make the change to be a 1. You just multiply the entire row by -1. So yes, that would be what we do. In fact, if you can do that, and it's pretty easy to do that in one step. Okay? So the first thing we're going to do is, and here's how I'm going to write it. Before I put equations, now I'm going to put row. I'm going to put minus row 1 becomes, well, minus row 2 becomes row 1. And row 1 becomes row 2. Okay? In other words, switch the rows but negate the first one. So what would the next equivalent matrix be? 1, -2, 0, -3. Next. I'm sorry? 0. No, you don't have to negate this one yet. 3, 4. Third row, didn't do a thing to it. 2, -3, 4, 1. Okay. Now, let me say this about matrices. The actual operations with them, pretty simple. You're adding, subtracting, multiplying, dividing. Really simple and generally pretty simple numbers. Okay? What's sort of bad about them is they're tedious. Okay? They take a lot of room to write, and you have to be careful on your bookkeeping that you don't forget to change the sign. You have to be pretty careful with that. So that was what makes them a little tedious. They're all simple, but you just have to do that. Now, by doing what you just did, notice here you've got a couple things up. First non-zero entry here is a 1. You don't have zeros completely below it, but you have the first one below it. So you've taken care of 2 steps now, 3 steps really. Okay, second row, first non-zero entry is 1. You just got to get that to become a 0, too. So that would be what we would do. First, get the 2 to become a 0 using that leading 1. Get the -3 to become a 0 using that leading 1. And then you would have it in row echelon form once you get those two zeros into place. Okay. Now it's not asking you to do that, so I'm not going to. Otherwise, it would take way too long. So let's look at the B problem. Okay, here's the B problem. 2, -4, 6, -2, 1, 3, -3, 0, and 5, -2, 1, 2. Okay. What would be, to have this in row echelon form, what would be the first feature you want? The 2 to be a 1. How could you make that happen? Okay, certainly that is one possibility, exchange row 1 and row 2. Just like we did before, only we negated one of those. This would be even simpler. But, do you see another way to make that happen?
I say subtraction.
Subtraction? Is that what you said? In other words, subtract this row from that row? Row 1 minus row 2 is the new row 1. Okay. You certainly, notice every one in that row is a multiple of 2. So you could divide the top row by 2, and that would be, I think, even simpler than the other one. Okay. So that would be a good, but both of them are correct. Yeah. Now, when you say divide, that's multiplying by 1/2. Either way you want to do it, I like to think of it as dividing. Row 1 divided by 2 is the new row 1. And what would that be then? 1, -2, 3. What do you say? -1. And then the other rows you leave alone. 1, 3, -3, 0, and 5, -2, 1, 2. Okay, again, you're writing down a lot of stuff over and over and over. That's what makes it tedious, and it also takes so much room, because you're doing it. Now, just what would be the next thing you do to get it in row echelon? I'm not going to do it, but just tell me what you do.
You can change any row and multiply by -5.
Okay, I would first get this to be a 0. Do -1 times that plus this. That's the entire row. Then, exactly what you said, -5 times this one plus that. That would be it. So yeah, those would be the next 2 steps I would do to get it in row echelon form. They just ask you to do the first step. They didn't quite, but that's what they did. All right, I'm going to clear these out of the way because I wrote too big. And let's come up with the third one. Here is the original matrix. 1, 2, -4, 3, 0, 3, -2, -1, and 2, 1, 5, -2. Okay. Now, what is the first step to having that in row echelon form?
It's already a 1.
Okay, the first step is done for you. 1 in the upper left. Next step.
And that's to get the second row to have 1 and 3.
Well, okay, actually what you want is a 0 below it. That's already done for you. Okay, and then the next step. The 2 also to be a 0. You want 1 here and zeros below it. So you want that to be a 0. So let's do that step. How do you get that 2 to become a 1? That'd be a 0, sorry. Yeah. By the way, use that leading 1.
So you want to use the first row to hit.
Yeah, use the first row to get that to be a 0. How do you make that happen? Okay, not quite. Okay? Here's how I think of it. If I want that to be a 0, I need to add a -2 to that. How do I get a -2? Multiply -2 with 1. -2 times the first row, add it to the third row. That gives us a new third row. So, -2 row 1 plus row 3. That gives you the new row 3. Okay, so in other words, and here's the tedious part, write down the first 2 rows. 1, 2, -4, 3. Okay, 0, 3, -2, -1. So you're doing a lot of writing down the same thing over and over and over again. But now we're changing the third row, and what does it become? 0. Very good. Yes, -3. Next. 13, yeah. That'd be, okay, next. -8. Fantastic. Well done. 0, -3, 13, -8. Okay? Now, I'm kind of glad we're not going any further, okay? Because the next thing we would want would be the first non-zero entry in the second row to be a what? What's the next step we would do? We're not going to do it, but we're going to...
Oh, make that 3 into a 1?
Yes, exactly. We want one of these to become a 1, okay? And the bad news is, to make that happen, we would need to divide one of these 2 rows. This one divided by a 3. That gives you fractions in these 2 places, which are okay. It's fine. You know, you can even have irrational numbers if you wanted to. But we prefer integers, but we can't live with them. You'd have to divide this one by -3, which would be even worse because they're worse fractions. So I would go with that. However, before I did that, now this is where you learn to cheat a little bit, okay? Or actually, I tell most of my classes, I have this theory about mathematics. I think your best mathematicians are inherently a little bit lazy. Do either one of you qualify? Oh, okay, good. She's sort of lazy. Okay. If you're a hard worker, you can still do math. You can still do math, but to be really good at it, I think you need to be a little lazy. So here's what I'm going to suggest. Why don't we go on and add these 2 rows together first to get your 0 down here? Okay? Yeah, add those first, then go back and change this to a 1. Okay? So you can divide by 3 then. And that way you won't be messing with your fractions, but you already get that to be the 0 you want. Okay? And then you'll be that further along the row echelon point. And then ultimately you would be dividing by 11, because when you add these 2 rows together, that's going to give you an 11 here, and that's going to give you a -9 there. So that last one is going to be, if this is a system of equations, z is equal to -9/11. What a nice number. But it still could be your solution. Okay. But we're not doing that. They just wanted you to do one step, and that was a step. I like you to look ahead to say, well, what would you do next? Okay. So let's go to example 3. Okay. Now, sometimes I think the book is a little lazy too, or Ron Larson may be, because they're going to start with a linear system. And unfortunately, I've already erased it, but the no, I'm sorry. It's not quite the same. Okay. I think I will erase what's here. I always look to check to make sure he's not redoing the same thing. And he is. I thought he was, but he's not. All right, here's a linear system of equations. X minus 2y plus 3z is equal to 9 minus x plus 3y is equal to negative 4. 2x minus 5y plus 5z is equal to 17. I think we've seen this before. It was on a previous page, but I was wondering if it was on that page. All right. I think when we were in section 1.1, we actually solved this using equation operations. What we're going to do now is write that as a matrix. What kind of matrix would we call that? 3 by 3. It'll be a 3 by 4 ultimately, because we're going to use the augmented matrix. Yeah. Okay. We're going to do the augmented matrix and go from there. So this becomes, give me the augmented matrix. Okay. Now, my 0s and 4s look way too close to each other, so let me clean that up just a little bit. Why is this not coming up? There we go. All right. That's a negative 4. The other one's a 9. Goodness gracious, this is... There we go. Okay. That's a 0 in front of it, 9 above it. Okay. Now, what I was just about to say, sometimes in the past, some text I've used, when they do an augmented matrix, they'll do sort of a dashed line down here, indicating this is coefficient, that's the constant. Okay? I kind of like doing this, but this author doesn't, so if I throw that in sometime and you say, what's he doing there? That's what I'm doing. I'm trying to not do those, so I think I got my habit broken now, but I still kind of like doing it because that reminds me these are coefficients, these are your constants. Okay. What do we want to happen for this to be in row S14? Okay, that first entry is just what we want. A positive 1 there. What do we want next? 0 here, and then later we're going to want a 0 there too. You know, I can do both of those at one time because I'm just using the first row and changing these two. So we're going to do both of those in one. It's going to be one new matrix, but I'm going to do 2 steps to get there. So what do I do to make that negative 1 and 1? What would be the operations? Yeah, row 1 plus row 2 is the new row 2. So let's do that. So I'm using row 1, so I'll write it down. 1, negative 2, 3, 9. Okay? Now you tell me what the new row 2 is. 0, 1, 3. That's a Negative 4.
Plus,
That's a 9.
Yeah, my fault. Yeah, 5.
5. Okay. Now, what do we want to be the next feature?
2R1 plus R2. Plus R3. Well, pretty much times the first row.
Okay.
2 times the first
Okay,
row.
only not 2. Minus 2. You have to negate it to make it go to 0. Okay. So minus 2, row 1, plus row 3 is the new row 3. Okay? So let's do that one.
Are you learning me?
Yeah, well, either one of you.
So the first one is
0, very good. Negative 1, very good. Negative 1 again. Negative 1 again. You're stuck on negative 1s, aren't you? Okay. All right, good deal. What's the next feature you want to happen? You got a 1 in the upper left, 0 is below it. Good deal. Okay. Actually, the first non-zero entry in row 2, you want to be a 1. That's already done for you. We didn't have to do anything else. And then what's the second thing? Okay, how? What do you want to happen? You want the negative 1 to be a 0. How do you make that happen? You have to multiply. Just add it. You see? Okay. Just add row 2 and row 2 to row 3. Row 2 plus row 3 is the new row 3. Okay. So we're not using row 1 at all, so write it down. 1, negative 2, 3, 9. We're using row 2, so we're not changing it. 0, 1, 3, 5. Now what's your new row 3? 0, 0, 2, 4. All right. Now what's the next thing you want to happen? Notice what we got. First non-zero entry in row 1 is a 1. 0 is below it. First non-zero entry in row 2 is a 1. 0 is below it. What do you want the next one to say?
It should be a 1.
You want the first non-zero entry to be a 1. It's not. It's a 2. How do we make that a 1? Okay. Actually, you could. Okay. That is a legal move, except, notice what will happen. If you do row 2 minus row 3, you said, right? If you do that, this will give you a 0. That gives you a 1. Now you don't have that a 0 anymore. So that's why you don't want to do that. How's another way you can get that 2 to become a 1? Divide by 2. And this will give you 0 divided by 2 is still 0. 0 divided by 2, still 0. 2 divided by 2 is 1. And 4 divided by 2 is 2. So guess what you got? Z is equal to 2. So the last entry, and it's all right just to do it here. I'm just going to change this to 1, 2. So that gives us Z is equal to 2. Now what do we do? Yeah, the third column stands for your Z's. And if you got a coefficient of 1 there, that would be Z is equal to 2. Because remember, that's where putting the dashed line in here reminds me those are equal signs. So then Z is equal to 2. Okay? Then what's the next thing you do? We do back substitution. And this would be y plus 3z, right, is equal to 5. But we know what z is. Y plus 3 times 2 is equal to 5. It'd be y plus 6 equal 5. So y is equal to, second, -1. Perfect. And then what do we do next? Solve for x. This is x minus 2y, but y is minus 1, plus 3z, but z is 2, is equal to 9. So that would be x plus 2 plus 6 is equal to 9. So x is equal to, second, 1, exactly. So now we have our solution. 1, -1, 2. Second? Okay, sure. You got this part, right? Z is equal to 2. So then we look at this, remembering our first column reference, these are coefficients of x, coefficients of y, coefficients of z, our constants that follow the equal sign, right? So this equation said y plus 3z, but z is equal to 2, so y plus 6 is equal to 5. Subtract 6 from both sides, and you get y is equal to -1. See?
I'm trying to figure out, like, I understand z equals 2 from the third,
Right.
row. But why you had when you worked with the second row?
Yeah, now the second row, z is equal to 2. This is a system of equations. So from now on, z is going to be equal to 2. So this would be y plus 3z is equal to 5. That's what that stands for.
Yeah.
Equal sign. But z is equal to 2. So y plus 6 is equal to 5. Subtract 6 from both sides, and you get y is equal to -1. So you plug in 3 times z. Z is 2. Yeah, but you see, now it's a system of equations. They all have to work together. Okay? And this is what it gives you. Okay? And then once you get that y is equal to -1, you plug that in here. X minus 2y plus 3z is equal to 9. Y is -1, z is plus 2. So that equation becomes that, which is y plus 2 plus 6 is equal to 9. And then you add 6 and 2 is 8. You subtract that from 9, you get x equal 1. So you use what you got at the bottom to back substitute going up. So you wind up with an x value, a y value, and a z value. And then what I do, because there's so many opportunities to make a little dumb error in this, I like to go back and check my answer. So let's do that too. X is 1. Minus 2 times -1, that would be plus 2. 1 plus 2 is 3. Plus 6. 3 times 2 is 6. 3 plus 6, sure enough, is 9. Ha! That works. Let's do the next one. -1, -4. -3 would be -4. That's equal to -4. That works. This one, 2. Plus 5, -5 times -1 is plus 5, 2 plus 5 is 7, plus 5 times 2 is 10, 7 plus 2 is 17. Yes! All three of them work. So I'm a happy camper. Okay?
So on the third row, it should always give us the z, or
Whatever your last variable is. Yeah. When you get a 1 there, that equals that. Okay? Z equals, because this is a coefficient of z.
that's what you're trying to do.
That's what you're trying to get here. Exactly. And then you just back substitute as you go. What did I just do? I'm an idiot. Okay. I was tired of sitting on my keys. Okay. Let's see what they got. They got x equal 1, y is equal minus 1, z is equal 2. Good for them. So these are said to be in row echelon form. What makes a row echelon form? Leading non-zero in each row is a 1. Well, we did that, we got a 1. Zeros below those leading ones. And that's it. Row echelon form. And here's the other thing. This will be the feature. The leading ones step down going from left to right, up to down. They step to the right every time you go down. Now you might wind up, if you had a big enough matrix here, to skip one. That would be fine too, as long as if this was a bigger one, you have a 1 here, and then it may be ones over here. You have another 0 here, first non-zero entry. So in that case, then you won't have a unique solution, you'll have a family of solutions. But we'll get to that later. Now, this is row echelon form. There is another form called reduced row echelon form. Now, what would that be? Well, this part of row echelon form is going to be the same. What makes it different now is you try to get zeros above the leading one as well as below. Okay? And when you do that, then your answer is going to be this equals this, that equals that, this equals that, without any back substitution. And that makes it easy on that, but you got a few more steps to do in here before you get there. So it's pay your money, take your choice. You've already paid your money, so you take your choice. Okay? So that's row echelon form as opposed to reduced row echelon form. Okay, the next example, okay, wait a minute. I think we're out of time, aren't we? Oh, I'm so sorry. We're just beginning to have fun. Well, we're always having fun. Okay, so we'll pick up there. We'll pick up an example 4 next time. It's a really easy example. Okay. This is a long section. Okay. So try to do any of the odds 1 through 5. Remembering caltech.com, first the answers are in the back for odd numbers. Secondly, caltech.com works them out for you if you need to see that. So any of the odds 1 through 5, that's real simple. Finding size of matrix, really, really simple. Number. Then do either 7 or 9 or both, and that's pretty simple. Then do any of the odds 11 through 17. I think that's not too bad. Then do any of the odds 19 to 23. Then do any of the odds 25 through 37. Second, any of the odds, okay, yeah, 19 to 23, any of those odds, and then any of the odds 25 to 37. Okay. And it says use a software program or graphing utility to do number 39. Try it to see if you can do it without, and if it gets too bogged down, then just skip it. If you have a graphing calculator, teach yourself how to use it. Okay, and we're going to stop there because the next thing is getting into homogeneous equations. We haven't gone there yet. Okay. In fact, where do we go there? Okay, yeah, okay. Good deal. Then we'll see you Thursday.